Hello everyone, I am Siddharth and I am from University of Florida. Today I'm going to present my course project in EEL6509 wireless communication. The topic of my project is PAPR reduction using high power amplifier and clipping reduction technique. First, I would like to give an overview on what is going to be in the presentation. I'm going to discuss about the following topics: purpose of this paper, introduction to OFDM, OFDM principle, what is PAPR, PAPR reduction techniques, amplitude clipping, simulation results, and finally the conclusion. The purpose of this paper. In this paper, we study about the amplitude clipping technique and how it reduces the problem of peak to power average ratio with the help of an high power amplifier. We use MATLAB to do the simulations of the code, and we produce graphs in this paper to show the difference. We tabulate and compare the values that show that PPAPR is reduced when we use clipping. We also show that more PAPR reduction is seen when we use a high power amplifier. Coming to the introduction of OFDM. OFDM stands for orthogonal frequency division multiplexing. There are various multiplexing techniques used to increase high-speed wireless communication. Some of the techniques are code division multiplexing access and orthogonal frequency multiplexing division. Orthogonal frequency division multiplexing is one of the most advancing technologies in wireless communication in the present age. Many wireless standards like WiMAX, IEEE 802, LTE, and DEVB have adopted the OFDM technology in order to increase dramatically future wireless communications. OFDM is a subject of intense research in the broadband wireless transmission because of its robustness against multipath fading. Basically, it uses a large number of parallel narrowband subcarriers instead of using a single wideband carrier to transfer the information. OFDM transforms a frequency-selective wideband channel into a group of non-selective narrowband channels, which helps in making it robust against large delay spreads by preserving orthogonality in the frequency domain. It's a combination of multiplexing and modulation. In the OFDM, the bandwidth is shared by a lot of individual users. Like in AM, FM, BPSK, QPSK, they're all single carriers, but OFDM is a multi-carrier which has different carriers sharing the resources and are used to send information from source to destination. Every carrier may employ any digital modulation technique like BPSK, QPSK, etc. The main principle of OFDM is in OFDM the subcarrier pulse used for transmission is chosen to be rectangular. So the basic principle of OFDM is high-speed form of a multi-carrier modulation which is suited for transmission over a dispersive channel. Due to the Doppler shift in the channel, OFDM also has a frequency offset. What is PAPR? PAPR is peak to average power ratio. It can be defined as the relationship between the maximum power of a sample in a transmit OFDM symbol and its average power, where P peak and P average are the peak and average power of a OFDM symbol. Even though OFDM is considerably efficient, there is one major drawback, and it is the peak to power average ratio. High peak to the power average ratio results in bringing the OFDM signal distortion in the nonlinear region of the high power amplifier, and the signal distortion gives rise to degradation of bit error rate. If the high power amplifier is not operated in linear region with large power backoffs, it is really difficult and not possible to keep the out of band power below the required specific limits. This results in inefficient amplification and expensive transmitters. So, in order to utilize the features of OFDM completely, we need to study the characteristics of PAPR and the methods to reduce PAPR. So these are some of the PAPR reduction techniques. So in order to reduce PAPR, there are a number of techniques like partial transmit sequences, selective mapping, amplitude clipping, clipping and filtering, coding, tone reservation, etc. In this paper, we use amplitude clipping with high power amplifier to reduce the PAPR in the OFDM. It is one of the simplest methods to reduce PAPR and it's very effective as well. So the results show that clipping is a promising technique for the transmission of OFDM signals using realistic linear amplifiers. Coming to the system model, let us assume that the data bit stream is generated using a random integer generator block of MATLAB. In this paper, we use QPSK for modulating the data value. The length of the data block M is indicated by the vector y of 0 to m minus 1 of t, where m is the number of subcarriers. The complex envelope of transmitted signal is given by the formula given there. The peak to power average ratio is calculated by the following formula: P peak by peak average. Amplitude clipping. One of the easiest methods to reduce PAPR reduction is amplitude clipping. To limit the peak envelope of the input signal, a threshold value of the amplitude is set in amplitude clipping. So during the transmission of the signal, the values higher than the predefined threshold value are clipped, and the rest of the values, that is, the values that are lesser than the threshold value, are passed through the channel undisturbed. The following thing is explained in the diagram there, where xc of k is the clipped clipped signal, and x of k is the transmitted signal. The explanation in the mathematical form is given. During amplitude clipping, distortion is considered to be another source of noise. Clipping causes in-band signal distortion, which results in bit error rate performance degradation. Filtering technique cannot be used to reduce the in-band distortion. Clipping also results in the out-of-band radiation, which results in sending out-of-band interference signals to the nearby channels. Even though out-of-band distortion can be reduced by filtering, it might affect the high-frequency components of the in-band signals. But there's an advantage when you do filtering to the out-of-band distortion. They result in peak regrowth. That means that the signal after filtering operation may surpass the clipping level specified for the operation. But this problem can be solved by repeating process of filtering and clipping till the desired amplitude level is achieved. The figure shown is the flowchart of OFDM simulation. The input data undergoes QPSK modulation, and then the transmitter converts the input data from a serial stream to parallel sets. Each set of data contains one symbol for each subcarrier. So, an inverse Fourier transform converts the frequency domain data set into samples of corresponding time domain representation of this data. Specifically, the inverse fast Fourier transform is used for OFDM because it generates samples of waveform with orthogonal frequency components. Then the parallel to serial block creates the OFDM signal by sequentially outputting the time domain samples. The channel simulation will allow testing of clipping and effects of noise. When random data is added to the signal, noise will be simulated. The amplifier saturation is simulated by clipping. This takes care of a major problem, that is high peak to power average ratio. The receiver performs exactly the opposite what the transmitter does. The data is converted from serial to parallel. The time domain samples are converted back into frequency domain samples by fast Fourier transform. Finally, the parallel to serial block converts the data to serial, and demodulation takes place and the data is recovered. Coming to the simulation results, the simulation is performed in MATLAB, and here the first case what we do is we calculate the PPR without amplitude clipping, and from the results from the graph we can see that the PAPR value is found to be 0.5 dB. If you look at the graph closely, the highest value of the amplitude is the PAPR value. Coming to the next condition, the next condition is the PAPR reduction with amplitude clipping. This is all without the high power amplifier. So when we use amplitude clipping here, the PAPR value is found to be 0.4 dB from the graph, and it is still less than the one without amplitude clipping. Next, we calculate the value of the PAPR after the PAPR reduction using high power amplifier without clipping. Here we found out the value to be 1.8 dB, and which is really high compared to the other results. And the fourth condition is the value of PAPR after the reduction using high power amplifier with amplitude clipping, and the value is found to be 0.4 dB, which is shown in the. With this we can see that the value of PAPR is reduced more when we use high power amplifier, as there is a difference of 1.4 dB compared to the 0.1 dB in when we don't use high power amplifier. The results, to be more clear, are tabulated as follows. We have the QPSK and high power amplifier in the columns, and the difference in the PAPR with and without clipping is shown in the last row, which is in QPSK, just the normal QPSK, we have 0.10 dB, while when we use high power amplifier it's 1.4 dB. Coming to the conclusion, we can say that PAPR reduction is a very important factor in the transmission of OFDM signals. In this paper, we discuss about the basics of OFDM and the problems OFDM face due to PAPR. We use QPSK modulation, amplitude and high power amplifier to achieve the least PAPR value. The code is run in MATLAB and the results were shown and tabulated. We can see that when we do clipping in both normal OFDM signal and OFDM signal with high power amplifier, the PAPR reduction is more efficient. By looking at the difference in PAPR value with and without clipping, in both cases we can say that clipping always reduces the PAPR value to a certain extent, and also that when we use high power amplifier it is much more efficient. Thus, amplitude clipping is considered not only easy but also really efficient. This is the end of presentation, and coming to the code, this is the code, and we set the parameters first, where m is equals to 4, number of data points is set to 128, the block size is 8, and we generate a vector of random data points, and then we perform the QPSK modulation, and after that we do IFFT, inverse fast Fourier transform, on each block, and we convert the serial stream for transmission, and when the actual OFDM signal to be transmitted, we do the simulation without this code helps in doing the simulation without clipping, and later comes the clipping part, and after that we generate random complex noise, and then comes the transmitted OFDM signal after passing through high power amplifier. We do this without clipping first and then with clipping, and then later when comes the receiver. This is the receiver part, and we pass the OFDM signal through the channel, and then exactly whatever happens in the transmitter, exactly the reverse happens. FFT, fast Fourier transform, is performed and the data is demodulated. Thank you. This is the end of the project and presentation.